Hello everyone, welcome to TidyStat YouTube channel. In this video, let me show you how to calculate one sample t-test in SPSS. One sample t-test is a statistical method used to determine if there is a significant difference between the mean of a single sample and a known or hypothesized population mean. It's typically used when you have a single group of observations and you want to compare their mean to a specific value. And we can use this one sample t-test if the population standard deviation is unknown and the sample size is small. If we do this in this condition, the t-test is more appropriate because it uses the sample standard deviation to estimate the population standard deviation. And the procedure to conduct one sample t-test, the first one is let's formulate the hypothesis. The null hypothesis is there is no significant difference between the sample mean and the population mean. And the alternative hypothesis is there is a significant difference between the sample mean and the population mean. And next, calculate the t-statistics. Here, I'll show you the formula to calculate the t-statistics, but I won't explain it in detail because we will use SPSS to calculate it. Third, determine the critical value. Based on the desired level of significance, usually 0.05, find the critical value from the t-distribution table. Fourth, draw the conclusion. There are two ways to obtain the conclusion in this test, but I prefer to use the p-value option. If the p-value is less than the significance level, we reject the null hypothesis and conclude that there is a significant difference between the sample mean and the population mean. And if the p-value is more than the significance level, we fail to reject the null hypothesis and conclude that there is a significant difference between the sample mean and the population mean. Remember, here I said we fail to reject the null hypothesis, not we accept the null hypothesis. Why? Sometimes because if we change the subjects or if we change the sample of the data, the result might be different. Remember, in t-test we use sample, so another sample might conclude another conclusion. And last, interpret the results. If the null hypothesis is rejected, it concludes that the sample mean is significantly different from population mean or hypothetical mean. If we fail to reject the null hypothesis, it concludes that there is insufficient evidence to conclude a significant difference between the sample mean and the population mean. Now, let's get practical. There are 30 students mathematics score data from superior classes. Based on the previous hypothesis, it is concluded that the average mathematics score of top students is 80. Is there a significant difference between the average score of these 30 students and the hypothetical score? Now, let's calculate it. Before performing the one sample t-test, let's prove this sample that we use in this case is normally distributed. Go to Analyze, Descriptive Statistics, and select Explore. Here, let's select the variable that we want to prove or we want to test the normality. Click it and move to the dependent list box, and here, click the Plots options. Here, don't forget to check the normality plots with test, and at the box plot, click None because we don't want to see any box plot here. And then click Continue. At the display options, just click Plots because we only test the normality test without showing any statistic here. And then click OK. Great. At the output window, you see the test of normality table. You have two tests here, so you can draw two conclusions based on each test, the Kolmogorov-Smirnov test and the Shapiro-Wilk test. But remember, we use small sample size here. Our sample size is 30, so I prefer to use Shapiro-Wilk test because this is the recommended test to prove the data is normal or not. We see in this case, the significance value that we've got from this test is 0.052. And the significance level that we use in this test is 0.05 or 5%. It means that the significance value is bigger than the significance level, or the p-value is bigger than the significance level. We can conclude that the data is normally distributed. After proving the data is normally distributed, let's perform the one sample t-test. Sorry, let me delete it first and let's get back to the data view. and go to Analyze, Compare Means and Proportions here, and then select one sample t-test. Great, you have the dialog box appear on your screen. Select the variable that you want to analyze, click the arrow button to transfer it to the test variable box, and then don't forget to click the options here to set the confidence interval percentage. I'll just leave it by default because I love 95%. Remember, if we set the confidence interval is 95%, the alpha or the significance level is 5%. You can also select the treatment to the missing values, and I'll just leave it by default. At the test value box, this is where you type the hypothetical mean that we have. Here, let's type 80 because our hypothetical value or hypothetical mean is 80, and uncheck the estimate effect sizes because we don't want to talk about effect sizes here, and then click OK. Great, you see at the output table, now you have the t-test that has been performed by the previous test, and you have two tables here, the statistics table and the one sample t-test table. Let's interpret it one by one and let's draw the conclusion based on this test. At the summary statistics table, the sample consists of 30 match scores of 30 data. The average match score or the mean of the match score in this sample is 86.03. The standard deviation of the match score is 8.340, indicating some variability in the match scores. The standard error of the mean is 1.523, suggesting that the sample mean is estimated with a certain degree of precision. At the second table, you see the one sample t-test output. You see here, the test value is 80, which means this is the hypothetical mean that we use to compare in this test. The t here, this is the calculated t statistics. It measures the difference between the sample mean and the test value in terms of standard errors. Here, the value is 3.962. df, which means degrees of freedom, this is a parameter used in the calculation of the t statistics. It depends on the sample size and it's used to determine the critical value from the t distribution. Here, the t is 29. The significance table. This indicates the significance level of the test, typically denoted by alpha. It represents the probability of obtaining a result as extreme as the one observed, assuming the null hypothesis is true. In this output, the significance level is less than 0.001 for both one-sided and two-sided tests. The mean difference. This is the difference between the sample mean and the test value. In this case, the mean difference is 6.033, indicating that on average, the match scores in the samples are approximately 6.033 points higher than the test value of 80, or the mean difference is higher from the test value or from the hypothetical mean. 95% confidence interval of difference. This interval provides a range of values within which we are 95% confident that the true difference between the sample mean and the population mean lies. Here, the confidence interval range from 2.92 to 9.15. This means that we are 95% confident that true difference between the sample mean and the population mean is between 2.92 and 9.15. In this test, we use the alpha or the significance level for 5%. We can see at the significance column the p-value that we produce in this test, both from one-sided and two-sided test, or p-value for one-tailed test and two-tailed test is less than significance level. For one-sided test, we see that the p-value is less than 0.001, which also means that the p-value is less than 0.005 or less than the significance levels. We can see that here the null hypothesis is rejected. It concludes that the sample mean of the match score is significantly different from the population mean or from the hypothetical mean of the match scores. For two-sided test, the p-value is also less than 0.001 or the p-value is also less than the alpha, that is 0.005, it means we reject the null hypothesis, and we can conclude that there is a significant difference between the sample mean and the hypothetical mean, or there is a significant difference between the sample mean of the math score and the hypothetical mean of the math score. That's it. Hope this video will be useful. See you in another video.